combine, little bit of electricity is generated. So the topic, let me write again, is PN junction diode. Okay, now listen to this. I will take pure germanium or silicon crystal. I will take pure germanium or silicon crystal. Half of the crystal I will dope it with trivalent impurity. So this will become P type, and other half I will dope it with pentavalent impurity. So it will become N type. So P type means majority charge carriers are holes, and N type is majority charge carriers are electrons. So this side will be of holes and this side will be of electrons. And the junction that is formed between the P region and N region, the junction that is formed between the P region and N region, this junction is called as PN junction. What is PN junction? The junction formed between N region and P region is called PN junction. Now listen. Since this electron and this hole are very close to each other, they will start combining and they will start turning. So since they will start turning, electrons from that side will come here, holes will go there, and they will start spinning. So this will be combined, this will be combined, and this will be combined. Now, when they combine, what happens is little bit of current is generated. Now that current I will represent it by dotted power source. Means there is no power source connected. Their combination itself acts like a power source. That is the meaning. Their combination itself acts like a power source because little bit of current or potential is developed. And this is called as barrier potential. What is barrier potential? Potential developed near the barrier or near the junction is called barrier potential. Now tell me, how much of region belongs only to P? How much of region belongs only to P? Can I say only so much belongs to P now? And how much of region only belongs to N? Can I say only so much belongs to N? Can I say in between the region does not belong to either P or N? That region is called as depletion region because the region has been depleted. P also does not belong and N also does not belong. Now the same diagram, they have shown it in the textbook like this. I will show it to you. Check. See here, this is P type, pure positive. This is pure negative. Here, positive and negative have combined. So negative has come on this side and positive has come on this side. So can I say this region is your depletion layer because neither belongs to P nor N. This is your barrier potential because of holes and electrons combining, I have some potential. This is my PN junction, correct? And this whole system is my PN junction diode. Okay. Therefore, I want you to write down the side heading PN junction diode, draw this diagram, and below that I will give you the notes. Start. Write the side heading PN junction diode, draw the diagram, and below that I will give you the notes. Start. Now below the diagram, see this. You have to write this. Listen to this first. See this. When half part of silicon crystal is doped with trivalent impurity and half part is doped with pentavalent impurity, we get PN junction diode. And the border where the P region meets with the N region is called as the junction, that is PN junction. Also, while the junction is forming, electrons from N side will diffuse across the junction and recombine with holes on the P side. Means electrons from N side will come to P side and vice versa. Did you understand this much? After that, I'll give you the notes. So below the diagram, write down this paragraph. Okay, finished? Below this, write down. The potential developed at the junction, is called barrier potential. The potential developed at the junction is called barrier potential. The potential developed near the junction is called barrier potential. potential
Sir, repeat
developed,
one.
the potential developed near the junction is called barrier potential. Written, the potential developed near the junction is called as barrier potential. Full stop. Next line. The layer which is depleted of free charges. The layer which is depleted of free charges. The layer which is depleted of free charges. The layer which is depleted of free charges is called, the layer which is depleted of free charges is called depletion layer. The layer which is depleted of free charges is called depletion layer. The layer which is depleted of free charges is called depletion layer. Full stop. Below that, write down. A diode which is not connected to, a diode which is not connected to any external power supply, a diode which is not connected to any external power supply is called unbiased diode. A diode which is not connected to any external power supply is called unbiased diode. And look at the symbol. Now, in future, instead of drawing this whole diagram, instead of doing that, there is a symbol for this. So draw this symbol for a PN junction diode. This is the symbol for a PN junction diode. This is the symbol for a PN junction diode. This is the symbol for a PN junction diode. This is the symbol for a PN junction diode. Drawn? Now, in this topic, you will have to cover, see here, when this topic is asked in the exam, you will have to cover these 4 points. Now tell me, are you in a position to answer these 4 points? What is a PN junction? What is depletion region? What is barrier potential? And what is unbiased diode? Check your notes and tell me whether you are in a position to answer all these points. Okay? Now, look at MCQ 5 and tell me, can you answer MCQ 5? The barrier potential in a PN junction diode, a potential barrier in a PN junction diode is due to what? Look at the options and tell me what do you think should be the answer. The potential barrier in a PN junction diode is due to what? The potential barrier in a PN junction diode is due to what? That is the question. So you know when electrons and holes combine near the junction, little bit of voltage is developed. That means, can I say it is accumulation of positive and negative charges near the junction? Therefore, can I say D has to be the right answer? Because what is barrier potential? The potential developed near the barrier. And how does it develop? Because electrons and holes are combining there. So D will be the right option. Okay. Now, you drawn the symbol for a PN junction diode also. You have drawn the symbol for a PN junction diode. Next, write down biasing. BIASING. Last topic for your chapter. BIASING. Biasing. The topic is BIASING. BIASING. Now listen. Write down, you'll understand. When a diode is connected to an external power supply, when a diode is connected to an external power supply, when a diode is connected to an external power supply, it is called a biased diode. In the previous section, what did you write? When a diode is not connected to any power supply, it is called unbiased diode. Therefore, can I say when a diode is connected to an external power supply, it is called as biased diode? Just check. In the last section, what you had written, when a diode is not connected to any external supply, it is called unbiased diode. In this section, what will you write? When a diode is connected to a power supply, it is called as biased diode. Full stop. Next, write down. There are two types of biasing. There are two types of biasing in diodes. There are two types of biasing in diodes. There are two types of biasing in diodes. Look at the screen. Which are the two types of biasing in diodes? One is called forward bias. Another one is called as reverse bias. Right now, first one is called as forward bias, and the next one is called as reverse bias. There are two types of biasing in diodes. First one is called as forward bias, and the next one is called as reverse bias. Okay, so we will study what is forward bias. We will study what is reverse bias, and then the topic or the chapter itself is over. Okay, so listen to me carefully. See here, I'm doing forward bias. Okay, listen. I take a PN junction diode. Means this is P region, this is N region, this is depletion region. Correct? Normal. And listen to this. If I connect P region to positive terminal, and if I connect N region to negative terminal, this kind of biasing is called forward biasing. I'll repeat. If I connect P region of a diode to positive terminal of the battery, and if I connect N region of the diode to negative terminal of the battery, this kind of diode is called as forward bias. Now I'll tell you what happens in forward bias. Just look at this. P has holes, correct? Now, when the battery is on, look at the screen very carefully. P has holes, okay? Now, when the battery is on, these holes get attracted to negative terminal, correct? Because holes are positive. This negative terminal is negative. Now, since holes are attracted to negative terminal, they will start moving in this direction because they want to go to negative terminal. Therefore, can I say holes will go in this direction? Similarly, can I say electrons are over here? They will get attracted to positive terminal. Electrons are over here. They will get attracted to positive terminal. So electrons will want to go in this direction. like this. Therefore, can I say electrons will go in this direction? Okay. So tell me, if holes go in this direction, electrons go in this direction, can I say all holes and electrons will combine? All electrons and holes will combine. And what happens when electrons and holes combine? Lot of current is generated. That is why this condition is referred to as on condition. That is why this condition is referred to as on condition, because lot of current is generated. And can I say the width of the depletion region will keep decreasing because both electrons and holes are coming over here. So the region will decrease. Therefore, can I say in forward bias, the width of the depletion region will keep decreasing because from here and here, they start pushing the depletion region. So let me repeat. What is the definition of forward bias? When P region is connected to positive terminal and N region is connected to negative terminal, I get forward bias PN junction diode. So what happens? Listen to this. In PN junction diode, which is forward bias, holes and electrons both move towards the junction and they combine. And since they combine, lot of current is generated. That is why the state is referred to as on state. And in this condition, the width of the depletion region decreases because they are pushing it this side. Is this much clear? This is called as forward bias. Therefore, in your notebook, write on the side heading, forward bias. And draw the diagram that I have drawn on the screen. Right hand side heading forward bias and draw the diagram that I have drawn on the screen. Draw the diagram. Below that, write down the definition. Write on side heading definition. Okay, and write down when P region is connected to positive terminal. When P region is connected to positive terminal and N region is connected to negative terminal, when P region is connected to positive terminal and N region is connected to negative terminal of an external power source, when P region is connected to positive terminal and N region is connected to negative terminal of an external power source, we get forward bias PN junction diode. We get forward bias PN junction diode. We get forward bias PN junction diode. This is the definition. Now write down the side heading, working. Write down the side heading, working. Now write down the side heading, working.
We get forward bias.
Forward bias diode. Forward bias PN junction diode. Now write down the side heading, working. Now write the working very carefully. Listen to this. Write down. In forward bias, holes and electrons move towards the junction. In forward bias, holes and electrons move towards the junction. And recombination takes place. Okay, holes and electrons move towards the junction and recombination takes place. Full stop. Due to this recombination of holes and electrons, due to this recombination of holes and electrons, a lot of current is generated. Due to this recombination of holes and electrons, a lot of current is generated. This condition is referred to as on condition. This condition is referred to as on condition. This condition is referred to as on condition. Full stop. Last line. In forward biased diode, the width of the depletion region, in forward biased diode, the width of the depletion region decreases. The width of the depletion region decreases. Okay. Now write down side heading, reverse bias. Write down the side heading, reverse bias. Write down the side heading, reverse bias. Now look at the screen. Reverse bias is exactly opposite. See here, reverse bias is ulta of forward bias. For example, in reverse bias, P region is connected to negative terminal and N region is connected to positive terminal. Exactly ulta. In forward bias, what was it? P region is connected to positive terminal and N region is connected to negative terminal. In reverse, it is reverse. Reverse means ulta. That means P region is connected to negative terminal and N region is connected to positive terminal. Now see what happens. P region holes get attracted to negative terminal because it is oppositely charged. Can I say holes get attracted to negative terminal? So they will start going in this direction. That means they will start going in this direction. That means this direction. Also, can I say N region has electrons? They will get attracted to positive terminal. Therefore, can I say when electrons are attracted to positive terminal, they will go in this direction because they will have to go here. Therefore, can I say electrons go in this direction? Therefore, can I say holes and electrons are going away from each other? In forward bias, what was happening? In forward bias, holes and electrons were coming towards each other. In reverse bias, what is happening? Holes and electrons are going away from each other. Therefore, since holes and electrons are going away from each other, they do not combine. And since they do not combine, no current is generated. Because in forward bias, they were combining, so current was getting generated. In reverse bias, they are not combining, so current is not getting generated. And that is why this condition is referred to as off condition. This condition is referred to as off condition. Easy. And can I say, tell me what happens to the width of the depletion layer? In forward bias, width increases. Here, since they're going away, can I say width increases? Okay, so it is exactly the opposite of forward. Whatever you write for forward, exactly opposite you have to write for reverse. Therefore, write down reverse bias, draw the diagram, then I'll give you the notes. Start. So write down below the diagram definition. Write down side heading definition. If you look at forward bias, you have to write the exact opposite for reverse bias. So write down the definition. When P region is connected to negative terminal, when P region is connected to negative terminal and N region is connected to positive terminal, when P region is connected to negative terminal and N region is connected to positive terminal of an external power supply, we get reverse biased PN junction diode. 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 Written? Full stop. Next side heading, working. In reverse bias, holes from P side, in reverse bias, holes from P side and electrons from N side, in reverse bias, holes from P side and electrons from N side move away from the junction. Holes from P side and electrons from N side move away from the junction, and hence no recombination takes place. And hence no recombination takes place. And hence no recombination takes place. Full stop. Due to this, no current is generated. Due to this, no current is generated. Due to this, no current is generated. This condition Due to this, no current is generated. This condition is referred to as off condition. 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 Next line. In reverse bias, the width of the depletion region, in reverse bias, the width of the depletion region increases. In reverse bias, the width of the depletion region increases. In reverse bias, the width of the depletion region increases. Right, on homework 1, you have to draw the graph of forward bias. We have done forward bias working, so now you have to show the graph of forward bias. And homework 2 is you should show the graph of reverse bias. Homework 2 is you should show the graph of reverse bias. Okay. Now, I will show you one more thing. See here, for an unbiased diode, listen to this, for an unbiased diode, the width of the depletion layer does not change. For a forward biased diode, the width of the depletion region decreases. And for a reverse biased diode, the width of the depletion region increases. This you can write it as summary. For an unbiased diode, the width of the depletion region is unchanged. For a forward bias, the width of the depletion region decreases, and for a reverse bias, it increases. So make a note. For an unbiased diode, the width of the depletion region is unchanged. For forward bias, it decreases, and for reverse bias, it increases. Okay. See here. Come back to your book back. Come to your book back. We will discuss questions and then we will stop the chapter. Come to your book back. Last page of the textbook. See here. We have finished first MCQ. Correct? Second MCQ you do not have. So cancel it. Second MCQ you do not have. Third MCQ is your homework because that answer you can get from the graph of reverse bias. I'll repeat, the answer for third MCQ, you will get it from your graph of reverse bias. So this is your homework. Now try to answer fourth MCQ. Start. And tell me what should be the answer for fourth MCQ.
Sorry.
Off switch.
Answer is off switch, correct? We have just done. The reverse bias is an off switch. Therefore, answer will be A. And the fifth one we have already finished. Therefore, can I say all MCQs we have done? Okay, one is not there, one is your homework, others we have done. So let me know if you have any doubt in your MCQs. You have finished 5 MCQs. Okay, now come to main question number 2. In that, this question is omitted. You don't have this from your deleted syllabus. Fourth one you do not have. Cancel it. First one we have finished. Second one we have finished. Correct? Fourth one you do not have. Fifth one we have finished. Can I say only third one is remaining? If I do the third one, can I say all the questions of second is done? Now read question number 3. What is it? What causes large current to flow through a PN junction diode when forward biased? Now tell me, when the diode is forward biased, why does large current flow through? Because can I say because holes and electrons
and more electrons.
Correct, because electrons and holes come towards each other and combine. Correct. You have just written the notes of forward bias. Tell me what happens in forward bias. Electrons and holes go towards the junction, then they combine. And because of this combination, large current is generated. Correct? Therefore, what is the answer? Why does large current flow through PN junction diode? Because holes and electrons combine. Therefore, write down the question. I will dictate the answer. Write down the question. Written. So what causes a larger current through a PN junction diode when forward bias? Answer is recombination of holes and electrons near the junction. Answer is recombination of holes and electrons near the junction. Recombination of holes and electrons near the junction. Recombination of holes and electrons near the junction. Clear? Now with that, my entire second part also is done. Now look at the third one. See here. See the third one. In that first one we have done, second one we have done. Look at the third one. Explain the importance of depletion region in a PN junction diode, which we have already done right now. What is the importance of depletion region in a PN junction diode? This is the question. This is the answer. When it is unbiased, the depletion region is unchanged. When it is forward biased, it decreases. And when it is reverse biased, it increases. Can I say the answer is direct? Therefore, this table is your answer for the question. Okay, this table is the answer for your question. Explain the importance of depletion region in a PN junction diode. So I've already written the answer. You can just draw that table where you have unbiased, forward biased, reverse biased. Fine. Can you manage that table on your own? Okay. Now see this. Question number 4. Explain the current voltage characteristics of a forward bias diode is nothing but the graph of forward bias. And this is already your homework 1. Check. What was your homework 1? To draw the graph of forward bias. So that is already done as your homework. So make a note. See the next one. Discuss the effect of external voltage on the width of a depletion region. Means I have to explain forward biasing and I have to explain reverse biasing in detail. Means in other words, I have to explain what is forward bias PN junction diode and I have to explain what is reverse bias PN junction diode. Can you manage to write that again? Not now, but if the question comes, you should write what is forward bias, full definition and working, and you should write for reverse bias, full definition and working. Okay, you should write full definition and working for forward bias and full definition and working for reverse bias if this question comes. Is it clear? So with that, we have completed all the book back questions. So just check and tell me if you have any doubt in any of the questions. We have completed all our book back questions. Just check and confirm.
Sir, show PN junction diode diagram.
PN junction diode diagram is here. This one. Anyone has any doubt? Let me know right now for the chapter.